Hi everyone, welcome to our first pre-recorded lesson for this course. And we're going to jump off right where we left off, which is solving inequalities. So let's get right into it. So the first question, it says, it gives us this expression or this inequality. We need to solve it for x. So I'm going to bring the constants to the right side up from the left and bring the x over. I end up with 3x minus x, which is 2x. On the right side, I end up with 6 minus 2, which is 4. Now I'm going to divide both sides by 2. And what I'm left with is x less than 2. So that's my final answer for this. And it's a good idea to draw a number line. So just put your 2 there. Draw some numbers on either side of it to show scale. And x less than 2, you draw an open circle and then a line below it saying that anything below that number 2 is actually okay for the answer. So 1 is less than 2, 0 is less than 2. So x could be anything smaller than 2, but not equal to. Actually, that leads me to a good point. This is supposed to be an open circle. So if it's less than but not equal to, it's an open circle. If it's equal to, it's shaded in. So watch out for that, like I did. So in the second question, negative 2x minus 3 is greater than or equal to 7. So I'm going to bring the 3 over. It makes it positive, so that's 7 plus 3, or 10. Now I need to divide both sides by negative 2. On the left side, that'll cancel, leaving just x. On the right side, it leaves a negative 5. But be super careful here. When you divide by a negative, you have to flip the sign of the inequality. So this is a division on both sides by a negative. So if it's division on both sides by a negative, negative on both sides, you have to flip the sign. Okay, I'll draw my number line here. So x is less than or equal to negative 5, so I'll put a negative 5 here. Negative 4, negative 6. Smaller is to the left, bigger is to the right, by the way. And this is less than or equal to, so we have less than or equal to 5, so we fill in the circle. It's less than or equal to this. So anything smaller, that's supposed to be an arrow. Let me make it clear. It should be a very nice arrow, should be obvious. Okay, and that's our solution to number 2. Anything less than or equal to negative 5. For 3, our final question, I would recommend that you pause and try to figure out the answer to this. What you should get is x is less than or equal to negative 6. So pause the video for a second and try that. I'm going to show you how to do it. There's a few ways to approach this. I'm going to simplify left and right before I start. So I'm going to group like terms. That gives me 4x minus 24 on the left side, greater than or equal to 8x minus 12 on the right side. Now I'm going to bring all of my x things to the left, so I end up with 4x minus 8. It's greater than or equal to negative 12, and the 24 went to the other side, become positive. Group like terms. Divide both sides by negative 4. So that's a special situation here. So what this gives is that x on the left, negative 4 on the right, oops, 12 divided by negative 4 is negative 3. And what is it? Well, it's not greater than or equal to, it's less than or equal to, because we divide it by a negative. If you multiply or divide both sides by a negative, that's what happens. And finally, our number line, we've got a negative 3, a little bigger than that is negative 2, a little smaller than that is negative 4, less than or equal to, so shaded circle, less than or equal to. So these just happen to all be less than or equal to. Of course, it could have been greater than or equal to for a different question. And that's how we do these. So the next set of examples on the next slide are asking us to determine if the final statement is true or false, which means I'm going to be substituting in values for A, B, and C, and we'll have to determine if the final answer is correct or not. So I'll show you the first one. The first one says A is greater than or equal to B. So A in this case is 2. From the top, I'm looking at here, A is 2, so replace that. B is 0, so replace that. And then the final statement says 2 is greater than or equal to 0. Well, of course that's correct. So that's true. 2 is greater than 0. And the way that these work are exactly the same way. Just figure out the answers. So you should pause the video and try these. The answers should be false, false, and true. So again, pause the video, do them, and then come back. Welcome back. If you took a little pause, let's do the answers. This says 2 is less than -1. Or in other words, 2 is less than 1. Is 2 less than 1? No, it's not. 2 is greater than 1. So the answer is false. These are our final answers here. Next one, 2 times a, so 2 times 2 is less than or equal to -1. In other words, let me rearrange these actually so that they are a little better fit on the page. So for this next one, I don't know if I made it better or worse. Sorry about that. 2 times 2, that's 4. Less than or equal to, what does this give? 1. Is 4 less than or equal to 1? No, 4 is bigger than 1. So this is false. And the final question, 2c plus b. So 2 times -1 plus 0 less than or equal to 0. Let's work up the left side. 2 times -1, -2 plus 0 is still -2, less than or equal to 0. Is that true? Is -2 less than or equal to 0? Well, yes, it is, because it's a negative number. That's the definition. Okay, and if you want to convince yourself, you can make number lines. So for example, you can say -2, and the 0 is over there. Is it less than? Yeah, of course it is. It's less than. So you can make a little number line and just confirm your answer in case your strength it doesn't lie with negative numbers. Maybe you find them confusing. But this is how to do these examples. If you need a little extra practice or want that explained in a slightly different way, just go ahead and follow this link that should be in your PDF version of the notes, and it'll help you get a bit more understanding of what it means to have equality and inequalities, because remember we did equalities before this, equations before this. The next section is percentages. And so I'm going to go through this fairly quickly because this should be review. So for percentages, it says it's often normal to see values displayed as percentages. Percent means per 100, which really means to divide by 100. So 50% is the same as 5 over 100. So in other words, if we had 25%, this is the exact same as saying we have 25 out of a group of 100, or 0.25 is the decimal version of that. If we had 13%, that would be 13 out of 100 possible parts. That would be the whole, and that would be 0.13. And then if we had 156%, for example, bigger than 100, it means we actually have 156 pieces out of a whole of 100. So we have more than our expected group, which means we actually have 1.56 would be our decimal here. We have a whole, or 1, and then we have 56 parts after. So the way that I like to think about this is, you can go other ways with this. You can say, what if I had 4 people show up to my class out of like a total of 16? What would that be? Well, if you divide that out on a calculator, that gives you 0.25, which, and let me scoot this over a little bit, 0.25 is 25%. So fractions and decimals and percentages are all closely related. In fact, they're all identical. It just depends on how you want to represent the data. And what this means, for those of you that don't have the number concept, 4 out of 16 is the same thing as having 25 people in a group of 100. So many people find that more useful to think about, like 4 out of 16, 4 out of 20, what does that mean? Well, you can scale it up and think of it as, okay, well, 4 students showing up out of 16 is the same as 25 students showing up out of a possible 100 that were in that class. Okay, so something to think about there. And the fun fact on the side, a century is 100 years, a cent is 100th of a dollar, and so on. Whenever you see this word cent, it really tends to mean 100. So per cent means per 100. Just a little trivia for you. Percentages always add up to 100, so you can see here on the right that this large square here is made up of 100 little tiny parts. 10 of those parts of 100 are yellow, 40 of those parts are red, and 50 of those parts are brown. And so the percentages for this is super easy. 10 out of 100 are yellow, which means that we have 0.1 or 10% is yellow. 40 parts of 100 are red, so 40 of 100 means 40% are red. And then 50 parts out of 100 are brown, means that 50% is brown. And of course, these are all over 100, so they're super easy to work out. If you add up all the percentages, you get this. 100. Woohoo! All right. Percentages should always add up to 100 for most cases. Of course, there's special cases, but if you're thinking about a whole, like the whole piece here, the whole thing you're talking about, all its separate pieces should add up to 100% in the end. So on the next page here, we have a short example, just trying to get in our heads this whole 100% idea. If 49% of babies born are female, what percentage are not female? And so you've got 49% are female, and then the other part, which is not female, should add up to 100, because it's either you are female or you're not, generally speaking. And so in this case, our mysterious x is 100%, the whole, minus 49%. In this case, x equals 51%. So it's not saying that they're male, but not female. Again, we don't want to force ourselves into a binary situation here. But for the purposes of this question, we can say 51% of babies born are not female. We're using this idea that they all add up to 100%. So that's all there is to this question. So on the next page here, we have conversions, which is something I kind of alluded to earlier. You can convert from percent to decimal, decimal to percent, fraction to percent, fraction to decimal, all the different ways, right, back and forth. And so I'm just going to go through them one by one, how to get from one to the other. So from percent to a decimal number, something that has a decimal in it. To convert this way, divide by 100, then remove the percent sign. So strictly speaking, if we take 74 and divide it by 100, we get a decimal, which is 74. And notice I've removed the percent sign. I kind of did that along the way. So we had 74%. Just get rid of that percent sign and make sure you put it over 100, because that's what percent means. Kind of a better way or an easier way to think about this, so I'll just put or, is this pro tip down here to move the decimal 2 places to the left and remove the percent sign. So we have 74. If we take our decimal here, which is at the end, if it's not written, it's at the end, just move it 2 places to the left. That's where our new decimal place is going to be. So really we have 0.74 or 0.74 is our answer. And that's a lot faster than thinking division by 100, but whatever works for you. They do the same thing. So in this case, 8.5%, I'm going to take the decimal, move it 2 places to the left. That would leave a space where we'd need to put a 0. And so cleaning that up a bit, 8.5% is 0.085. That would be our final answer here. So I've just moved the decimal to the left. If I needed to jump past a space where there wasn't a 0, I had to add my own 0. And notice I added a 0 to the beginning as well. And of course, you could also take 8.5%, remove the percent and divide it by 100, put this in our calculator. It gives you the exact same answer. So you need to just choose the method that works best for you. So next we're going to go and do the opposite. Decimal 2%, multiply by 100, then add the sign. So 1.24 multiplied by 100 is 124, and I add the percent sign. All right, nothing to it, that's it. Next one, multiply it by 100 and add the percent sign. Well, let's take this little pro tip here again. We move the decimal places 2 places to the right and add the percent sign instead of taking it away. So 1, 2 to the right, that's where my decimal is going to live now. So 7, 5, and add the percent sign. Once again, any zeros in the beginning called leading zeros, because they lead the number. once you've moved the decimal to the right, we get rid of it. And the reason for that is, if you think about this, you end up moving the decimal to the right, you get 75 decimal. There's no reason to have that 0 in front anymore. It doesn't make sense. I mean, you can always have 0 in front of the number, but it doesn't help. So we're going to leave the number like this. This is how we convert from decimal to percent. And so if you skip forward a bit, you'll see that there's a decimal to percent review, which if you want to watch that, it'll cover what we just did. And then we're going to move on to a quick exercise here. So complete the table. We've got fraction, decimal, and percent. I would like you to pause the video here and try to fill in this table as much as you can. And I'm going to fill in the table myself and compare your answer, okay? So 5, 4, 3, 2, 1, and boom. This is the answers that I got. You'll notice here on the left side, the fractions. I've given the simplest, I gave the simplest forms here on the side, and then as an alternate representation, I gave it out of 100 just for reference, but the simplified version on the left is really what you should be writing down, because that's the smallest form and easier to think about. This second one here, 5/1, is kind of a special case. There's no real need to write 5/1. You could have written 5, but just for completeness as a fraction. Just take a moment to go through each of these answers and try to make sense of them yourself. If any of them don't click with you or you don't agree with my answer, make a note of that for yourself, and then you can let me know in our next live class. As for practice, on D2L, there's a few practice activities, and you can go find those. The two practice activities you should find are converting from percent to decimal, and then converting from decimal to percent. And so you should take a few minutes to try these online. You should be able to check your own answer. I'm going to post the final answers here so you can check against them. And here they are, so you can check your work. The big thing to remember is that if you're going from percent to decimal, you move the decimal to the left and remove the sign. And if you're going from decimal to percent, you move the decimal right and you add the sign. Those are the really big differences. If you keep that in mind and practice, you should have no trouble. Let's move on to actually calculating percentages given some sort of a word problem or a practical problem. So in order to solve more practical problems, we're going to want to structure our thinking, and we're going to use an equation to do that. So to calculate the percentages, this is the equation you should be always thinking in the back of your mind. So a percentage, which is our percent, is going to be a part or a piece of something divided by the whole. So if we were to think of this in terms of, like, I don't know, pizza, classic example, we split it into a few different parts here, and we wanted to figure out, okay, how much pizza is this, for example. Excuse the bad shading here. We would want the part divided by the whole. Well, if we count up this pizza, the percentage we're looking for of the red, or the pizza that's left over, I guess, after it's been munched on, whatever way you want to look at it, this red part, the part out of the whole, well, the whole is 1, 2, 3, 4, 5, 6, 7, 8 pieces, and the part that we're talking about is 5 pieces, so it's 5 divided by 8. And so you would divide 5 by 8, and you would get 0.625. Or as a percent, move the decimal twice, 62.5%. So that red part of the pizza is 62.5% of the pizza, and if we wanted to figure out what was left over, we would just take it away from 100. So 37.5% is left. Or I'll say not red. Okay, so just a little side sequence there. So let's try exercise 1. If you want to pause it, well, you don't need to pause it. The answer is here. But you can pause it to try it yourself, and then come back and see how I do it. See if it matches up. So a jar contains 1,199 red marbles and 485 blue marbles. So it's just a red. We're just talking about red and blue here in this jar, as we can see to the right. This is a total of 1,684 marbles, which is 100%, so there are no other colors. What percentage of the jar contains blue marbles? So we'll just say percentage, or sometimes I'll just write the percent symbol just for shorthand. is the part over the whole. So I'll write that out. Part divided by the whole. What's the part that we're talking about? The part that we're talking about is blue marbles, because that's the question. Might as well color code. Blue marbles. How many blue marbles are there? 485. What's the whole? What's the total amount? 1684. If you divide one by the other, you end up getting the decimal 0.288. That's not a percentage, so we want to move the decimal place 2 to the right, just like we learned a few minutes ago. And then we have 28.8%. That's our final answer. That's how many blue marbles we have. So if we had 100 marbles in there, about 28 to 29 marbles would be blue. So one way to think about that. If you wanted to figure out how many are red, you would do the subtraction out of 100, and you'd see that 71.2% are red. So if you had a group of 100 of these marbles, on average, you would have about 71 red marbles and about 29 blue marbles. Let's move on to another example. So in this question, we have something that people encounter every single day, most of the time, at least if you're out shopping, and it's discounts. So original prices of items being marked down, or sales, things like that, deals. Especially around the winter season, people tend to have a lot of sales. So let's see how to analyze them. The original price of a winter jacket is $50. The jacket has been marked down to $39. What percent discount is this? And the tip says it's easiest to find the size of the discount first. So you can pause the video and compare your answer to 22%. See if you get the answer 22%. Okay, so try that first. If you've done it and you got it, then we're all good. You can move on. If you didn't get it, make sure you watch this and see how I approach it. I approach it in 2 different ways. So the first method, which I find a little easier to understand, is to figure out the discount first. So the percent discount is what you're looking for. So let's find the size of the discount. Well, the original price was 50. If we take away the marked down price, 39, we ended up getting 11. So that's the size of the discount. We have an $11 discount. And compare that to the original price, that will be the percent discount if we compare it part over whole. So the part over the whole formula we have, the part in this case is the discount amount over the original amount. If you divide 11 by 50, you get 0.22, which is a decimal, not so useful. So move the decimal or multiply it by 100, whatever way you want to think about that. You end up with 22%. So the final answer here, the percentage discount, or a sale, is 22%. That's 22% off, is what you would see in a store. Usually it's 20% off, but that's what it means. A second method, which some students prefer, and it's up to you which one you choose, is to figure out the marked down price as a percentage and then take that away from 100. So it's been marked down to 39. So again, we can do the part over whole formula. We have $39 out of the original $50. This is what we're paying. We're paying 39 out of 50, which is 0.78. Again, change that to a percentage. It's 78% of the original price. That's what we're paying. So the amount that it was reduced by, or if we can say the sale price is 78% of the original, that, if we subtract 100, would be the discount amount. So the sale price is 78% of the original. So you saved 100 minus 78%, or 22%. So the first method, you figure out the size of the discount and compare that to the original price, the whole. You get 22%. I prefer that method. The second way would be to get the marked down price and then subtract that from 100 to get 22 as your discount. Whatever way you slice it, you're going to get the same answer. Just choose the way that works best for you. We're going to try a few more examples now, but we're going to use the same formula transposed, which means the same formula, but it's written in a slightly different way. So we can transpose the percentage formula to solve more problems. And the new formula ends up looking like this, which is actually the original formula, so just follow my logic here. The percentage was equal before to the part divided by the whole, or the part out of the whole. That's your standard percentage. But if you rearrange it, divide both sides by this whole, and now whole and percentage are a product on one side, leaving just the part, we end up getting part is percentage times the whole. So it's actually the exact same formula, just rearranged. And we can use that to solve problems. So let's look at exercise 3. What is 10% of 16? And the tips here I've shown you are a really nice way to remember how to do these problems if you're not so solid with this stuff. It says replace what with x. So what is something we don't know. Replace is with the equal sign. What is? Replace of with multiply, or the multiply sign. Of. So something is 10% of 16, and we just fill these in. 10% of 16. Or read as math, x is 10% times 16. So our part, or our x, you can call it x, you can call it part, it doesn't matter, is 10% times 16. So you can just multiply those, or change it to a decimal first. And our answer, our mysterious part, is just going to be 1.6. So 1.6 is 10% of 16. All good. That's all you need to do for this question. Let's try one that's a little bit trickier. Applying percentage concepts, and this is sales tax. So one of the most important or common percentages is sales tax. So in Newfoundland, we have 15% sales tax, which is huge. It's called harmonized sales tax. And yeah, it's big, so that's why we pay so much for things that shouldn't be as much money. Anyway, when you buy something, you add extra money on top. So let's say you buy an 18-inch honey garlic fingers from Luigi's for $19.75. What you see on the menu is $19.75, but really the HST, the tax, is 15%. So we got to take that original cost, and then we got to find the total cost of the food with tax included. So that's the real bummer here. In this country, we have tax. In somewhere like Doha in the Middle East, you don't pay tax, so what you see is what you get, which is great. The answer here is 22.21. If you want to pause the video and try it and see if you get 22.21, this is your time to do it. For those of you that want to check and see how I'm going to do this, I'm going to first do it as a two-step method. I'm going to find 15% of the cost and then add it to the price. So my first step, I'm going to go 15% of the cost. So 15% of the cost, $19.75. In math, that would be 0.15 multiplied by 19.75. If we calculate that out, 0.15 times 19.75, that gives us 2.9625. And because this is money, let's just round it to the closest cent. Okay, so 2 decimal places is the closest cent. This is the tax. That's the sales tax, or the HST, harmonized sales tax. Second step, I found 50% of the cost, I need to add it to the price. So I have $19.75. I'm going to add my tax, $2.96. Again, this is just in case you already forgot where this came from. That was the tax that we just got. Let's figure out what that's going to be. 19.75 plus 2.96. I should get 22.71. Which, when I compare it to my answer here, 22.21, it looks like I did something wrong. So let me just quickly check my calculations. Yeah, it looks like everything's okay. So I believe this was just a typo. It was supposed to be 7. So if you tried it yourself and got 7-1, not 2-1, and you're like, what the heck, why am I doing it wrong? Well, you weren't doing it wrong. I was doing it wrong, or I got the answer wrong. But that's my first approach to doing this problem. I'm going to show you another way to do this same problem, but that can take a little less time. So this is our next example. It's actually the exact same exercise, just I'm going to be doing what I'm referring to as the shortcut method, which is to find the percent increase, which is the amount that we're going to have to pay with tax included, by finding 115% of the original price. So let's go ahead and do that. We have a percent, 115% of the original price. So I had 100% to start with. You know, I'm adding 15%. That's kind of my total amount that I'm going to be trying to figure out here. Multiply that by the original price. That'll give us the exact same answer in one big step. Okay, so 100 plus 15 is 115%. I'm going to multiply that by 19.75. Convert the percent to a decimal, you get 1.15 times 19.75. This is a real key here. This 1.15 is kind of the most important part of this question, which we'll talk about in a second. So when we get this 1.15 times 19.75, that gives us a final answer of 22.71, which again, I made a little mistake when I wrote out the answer here. It's actually 71. So what's so important about this 1.15? Well, it relates completely to the HST. So if you have tax that's 15%, you just multiply it by 1.15. If you had tax that was 20%, you'd multiply it by 1.2. And that's what this pro tip is saying. The shortcut for calculating prices with tax is convert the tax to a decimal. In this case, 15% turns into 0.15. Add 1, then multiply it by the item's price. Okay, so for example, a 25% item subject to 15% sale tax would be 1.15. So just take the harmonized tax, put it there, and put 1 point that times 25. As a little side note, what if you had like a $45 shirt and you had something crazy, 22% tax? The numbers don't matter. All you would do is you'd say, okay, I've got my $45 and I'm going to multiply it by 1.22, which is 100% the original price, and add an extra 22%. And that'll get you your tax really fast. So those of you that don't do that when you're going out and buying things, that's something to keep in mind. It's a really nice, easy way to know what your tax is going to be. Or, you know, you go to the movies, go see a movie, and you know that the ticket is, I don't know, let's just say it's $10. You can whip out your calculator on your phone and go 10 times 1.15, and you know that's going to be $11.50, for example. Just something to keep in mind, okay? So this is how we do these percent increase questions. The rest of what's expected of you is to do the practice examples on D2L, which are these questions, which I'll post the solutions to in a second. So 3, 2, 1, boom, here you go. Try all these out, see if you get the same answers as I do. You can also check your work on D2L without having to go here. And finally, the longer questions, a little bit more involved. These questions are going to take you a little longer to try, but you know, take as much time as you need to work them out. And I'm going to put up the answers here so you can see if you're right. So 3, 2, 1, and here we go. So try all these questions, see if you can get all the answers. A basic version of their answers are online. And if you still can't get it and you need more help in class, that's what I'm here for. Just mark down the exact questions that you're having trouble with and bring them to class. All the best to you, and we will see you next time.